Okay, so in this video we're going to do three example problems. We're going to solve three quadratic equations, two by factoring, and then one we're going to use the quadratic formula. So the first example is problem number 79 on page 637, and we're going to solve this quadratic equation by factoring. It's p plus 1/2 squared is equal to 9/4. Okay, so to solve this by factoring, the very first thing we need to do is to set it equal to 0. So that involves moving the 9/4 over to the left side. Now, before we do that though, we should square this binomial. And so to square that, I would have p plus 1/2 times p plus 1/2, and that equals to 9/4. Okay, so that's p plus 1/2 squared. And then I'm going to FOIL. So multiply p times p, which gives me p squared. P times 1/2 is plus 1/2 p. 1/2 times p is another 1/2 p. And then 1/2 times 1/2, that's plus 1/4. Because remember, when you multiply fractions, you multiply straight across. And then that's equal to 9/4. Okay, so now we combine like terms, which are these two right here. So 1/2 p plus 1/2 p, that equals to just 1p. And so then I have p squared plus 1p plus 1/4 is equal to 9/4. Okay, so now I'm ready to set it equal to 0. And I'm going to move everything over here to the right. So if I then subtract 9/4 from both sides to set it equal to 0, then I have 1/4 minus 9/4. That's negative 8/4, right? But negative 8/4, 8 divided by 4 is 2. So that is actually equal to negative 2. So in the next step, so I'm going to write it down over here. I'm going to have p squared plus p, and then what I got from that part, which is, we said just now, minus 2. And that now is equal to 0. Okay, so now I'm ready to factor. So let's do this. So this is a trinomial. And to factor this, so I'm going to open up two parentheses. And so remember, what you're doing is essentially you're doing what we did here, the foiling. You're just doing it backwards. So to get this p squared, I need to have p and p. And then what I need to do is I need to find two numbers. I need to find two numbers that multiply to minus 2, which is this number right here, and sum to the coefficient of the middle p, which is positive 1. So what are two numbers that multiply to negative 2 and sum to 1? Well, that would have to be the numbers minus 2 and positive 1. No, right? Because negative 2 times positive 1 multiplies to negative 2. But if I add them, negative 2 plus 1, that equals to minus 1. So that's not quite the sum that I want. I want it to sum to positive 1. So what do I need to change? I need to make this, the -2, positive. The -2, so this is +2, and make the 1 negative. Now they still multiply to -2, but now notice when I sum them, 2 plus -1, that equals to +1, which is what I wanted. So that tells me that these two numbers should be +2 and then -1. Okay, so now the last step is to use the zero factor property, and that is that p plus 2 should equal to 0. So this implies that p, if I subtract 2 from both sides, I would get that p equals to -2. Okay, and then the second one, I have that p minus 1 equals to 0. So that implies that p should equal to +1 if I add 1 to both sides. And these are my two solutions. And how do you check to make sure? Well, you would take those two numbers and then you would plug them into the original and make sure that both sides equal to each other. So I'm going to let you do that part because I want to move on to the next example. So the next problem is problem number 87. And that is minus x squared plus x plus 6 equals to 0. Now in this example, it's already set equal to 0, and I have a trinomial on the left side. But it's usually pretty difficult to factor with the negative sign in front of the squared term. So what I'm going to do is I'm going to make things simple for myself, and I'm going to factor out a negative or a -1. Okay, so what's going to happen? Well, inside the parentheses, I'm going to then have x squared, and I'm going to have to change all of the signs inside. So notice if you distribute the -1 in this trinomial, you would end up with the original trinomial. Okay, so now x squared minus x minus 6. Now I can try to factor that. So that's going to factor into two binomials. And just like we did in the previous problem, we are looking for two numbers that multiply to -6, which is this one, and sum to -1, which is this number right here. And there's an implied 1 in front of there because there's no number in front. Okay. And these two are x's. Okay, so what are the two numbers? Well, it would be -3 and +2. Because -3 plus 2 is -1, and -3 times 2 is -6. And then we use the zero factor property, so x minus 3 equals to 0. It implies that x equals to 3. And x plus 2 equals to 0 implies that x equals -2. And again, I'll let you check to make sure that that works. Okay, so now for the last example, we're going to do a quadratic formula problem. So the last problem that I have here is problem number 47. So I'll just put the 47 there. Okay, and the problem is we need to solve 3y squared plus 2y minus 4 equals to 0. And we're going to use the quadratic formula. Now, remember the quadratic formula says that x is equal to minus b plus or minus the square root of b squared minus 4ac all over 2a. Now, these a, b's, and c's, so this is corresponding to the standard form of a quadratic equation, which says that ax squared plus bx plus c equals to 0. So what does that mean? Well, that means that a is equal to 3, because a is right there. B would be the 2, so b is equal to positive 2, and then c would equal to minus 4. Okay, so if we plug those into the quadratic formula, and actually I just now realized that I used x, but really I guess for this problem it should have been y. So sorry about that. So y is equal to minus b, and since b is 2, so it's minus 2 plus or minus the square root of b squared, so that's 2 squared, minus 4 times a, which is 3, times c, which is negative 4, all over 2 times a, which is 3. Okay, so now if we simplify this a little bit, we get negative 2 plus or minus. Now you have to be a little bit careful here. So 2 squared is 4. And then I'm going to multiply these three numbers. So I have minus 4 times 3, so that equals to 12. And if you multiply 12 times negative 4, that's negative 48. Right? So 12 times negative 4. So the total of that is negative 48. So this is 4 minus negative 48. So I'm just going to write that as plus 48 because that's what that is. Okay, so this is 4 plus 48. And then that's all over 6. Okay, so that's minus 2 plus or minus the square root of 52 all over 6. Okay, so now the next thing we need to do is we need to simplify this radical. So notice that 52 is equal to 4 times 13. And so the square root of 4 times 13 is equal to the square root of 4 times the square root of 13. And the square root of 4 is 2. So the square root of 52 simplifies into 2 times square root of 13. Okay, so that means that I have, this is equal to minus 2 plus or minus 2 square root of 13 all over 6. Now the last thing we need to do is to simplify this. So notice what we can do is we can divide. We're going to divide by 2 on the numerator and on the denominator. And if I do that, you need to make sure that you divide both terms in the numerator. So the minus 2 gets divided by 2, leaving me with minus 1. And then this 2 gets divided by 2 as well, leaving me with square root of 13. You don't divide the 13 by 2 because that's inside of the root. So, and then in the denominator, I have 6 over 2, which is 3. And these are my two solutions, one with the positive sign and the other one with the negative sign. And if we plug these into a calculator, we get the approximate solutions, which are, so I would get 0 with on a calculator, obviously, 0.869, and the other solution would be minus 1.535. So I hope that helps you with the discussion assignment.